everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be solving a very interesting trigonometric equation with complex numbers. Cosine of z equals I. Wait, is this possible? Isn't cosine always between -1 and +1? Well, in the complex world, everything is possible. So let's go ahead and remember Euler's formula. There's quite a few ones, but the one that is associated with complex numbers is e to the power I theta equals cosine of theta plus I sine of theta. Obviously, you can prove this using Taylor's series. You know, there's a couple different ways to approach it, but we're not going to do that here. Here's what we're going to do. We want to get the cosine of something. Obviously, theta is our variable in general, but we can always change it to z and write this as e to the I z equals cosine z plus I sine z. So the difference between these two equations is usually z is a complex number, but when you write this with theta, most of the time theta is meant to be a real number like pi over 3. Make sense? It's usually expressed in radians, so on and so forth. But z can also be complex. Therefore, we're going to be doing some complex exponentiation here. All right, great. So let's go ahead and find cosine z from here, but we also have a sine z. And the way to get rid of that is considering the conjugate. Why did I say conjugate? Isn't that the reciprocal? It's actually both. So that's an interesting topic to think about. Like, when is the reciprocal of a complex number? Is its complex conjugate? Yes, the answer is when the absolute value is 1, because this product gives you absolute value squared, which cannot be negative, right? Of course. Anyway, so from here we get, when we replace z with negative z, we get cosine of z minus I sine of z, because cosine is even and sine is odd, right? So now let's go ahead and consider these two equations, add them, and then we're going to be able to cancel out the I sine z's, and we get cosine z plus cosine z. Let me write that on the left. 2 cosine z equals e to the power iz plus e to the power negative iz. My goal is to get to cosine from here, so let's go ahead and divide both sides by 2, and that's going to give us the formula. Of course, in the trigonometric form, this is very helpful, because if you had an equation like cosine z equals 1/2, you could solve it easily, right? You know the angle whose cosine is 1/2. But in the complex case, you don't know, maybe you do, I don't know, but in general, most people don't know the cosine, the angle whose cosine is I, right? That's really, really complex. All right, so let's go ahead and set this equal to I, because that's what our cosine z is equal to. And then now we're left with an equation like this. Yes, this is exponential. It contains complex numbers, but we can turn it into a quadratic equation by way of a really cool substitution. And guess what? That is replacing e to the iz with something. How about w? W is another complex number, because e to the iz is probably a complex number, right? Well, it is, because it's cosine z plus I sine z, right? Cool. Now, let's go ahead and replace e to the iz with w. But what is e to the power negative iz? It's just the reciprocal, so w plus 1 over w. And if I do cross multiplication, allow me to do it, you're going to get 2i. Multiply everything by w, w squared plus 1 equals 2iw. Put everything on the same side, and then you'll get a quadratic equation. We can solve it with the quadratic formula or completing it squared, doesn't matter, no big deal. But from here, w becomes, to keep a long story short for you. Do you want me to keep it short? Okay, I'll show the steps, whatever. Negative b plus minus the square root of b squared. Now, you got to be careful here, because this is b, and when you square it, you're going to get 4i squared, which is -4. Yay. And then minus 4ab or 4ac, it's going to be -4. Notice that most of the time b squared is positive or 0, but in the complex case, it can be negative. Cool. And divided by 2a, which is 2. And obviously, inside the radical, we have the square root of -8 which can be written as 2 root 2i, because this is the square root of 8 times I, and of course plus minus will take care of both square roots. There is 2 of them, but then this can be written as 2 root 2i. So w can be written as 2i plus minus 2 root 2i divided by 2. And then divide everything by 2, you're going to get 1 plus 1i, or just I, plus minus root 2i. Now, this can be written in a much better way. Let's go ahead and take out an I, and we're going to get 1 plus minus root 2 multiplied by I. Be very careful. Don't confuse or mix this with 1 plus minus square root of 2i, which is different, obviously, right? This is a multiple of I. That is not a multiple of I. So that's the difference. So those are different things. Anyways, so that's our number, but that's not the end goal, because w is what? E to the power iz, right? So let's replace or back substitute e to the iz, and we're going to get 2 solutions. Let me write this one and then the other one. And I'm just going to work with the first one, and the second one is very similar, and you could hopefully figure it out. The only thing you need to be careful about is whether the multiple of I, the factor, is positive or negative. In this case, it's less than 0, so you're going to be here, and your argument is going to be 3 pi over 2. And in this case, it's positive, therefore it's going to be pi over 2. Makes sense? So here's what I'm going to do. I'm going to go ahead and write this as follows. E to the iz, and I can write this as e to the ln 1 plus root 2i. I got to be careful. I'm not multiplying ln of something by I, but I'm lning something times I. Makes sense? So I got to use 2 sets of parentheses. And then from here, iz equals ln of 1 plus root 2 times I. And at this point, we got to remember the formula for the log of a complex number. I guess at this point, I could probably replace ln with log. Sometimes they will use log for complex logarithm, but I don't think that's a big deal. I'm just going to use ln. Hopefully that makes sense. But normally they would write it as log of a complex number. Make sense? And log of a complex number, like log of z, would basically be written as the ln of the absolute value of z plus I times the argument of z. So that's the general formula, and obviously this is multi-valued because the argument of z can be written periodically, and you can basically add 2 pi every time, right? But let's go ahead and go with the principal value because that's kind of simpler. And if you go off of that, from here, we're going to get the ln. Let's go ahead and find out the log of 1 plus root 2i, and I apologize, I used that interchangeable. Let's go ahead and replace this with ln, and then this is going to give me, by definition, ln of the absolute value, which is 1 plus root 2. Notice that this is the absolute value of this number, plus I times the argument of this number. But wait a minute, what's the argument? We said that it's pi over 2, because if you think about this number, it's going to appear here, 1 plus root 2 multiplied by I. That's a positive positive number times I, and my argument is going to be pi over 2. Therefore, I can just multiply by pi over 2. Of course, you're allowed to add pi over 2 plus 2 pi k for all the values, but I'm just going to use the principal value again. Okay? So, from here, what do we get? We get the ln of something equals iz. So this is iz. Iz equals this. So I'm supposed to find z from here. Therefore, I need to divide everything by I, or multiply by negative I. You can do both. Negative I is going to give us this, and negative I squared is positive 1. So it's just going to give us this. Therefore, I can write z as pi over 2 minus I times ln 1 plus root 2. So whatever ln 1 plus root 2 is, by the way, that's a real number, times I plus I pi over 2 is going to give you the answer. Let's go ahead and check. This is one of them, and the other one hopefully you can find. You're just going to have a different argument and just different ln. Make sense? Let's go ahead and take a look at some of the results. This is an alternative form. Obviously, we talked about it. And the solutions from Wolfram Alpha, kind of disappointing. I'm like, what? What does that mean? What is cosine inverse of I? Please give me a value. Anyways, our solution I think is better. And this is just a nice graph that I wanted to share with you. This is the graph of the imaginary part of cosine z, where z is x plus iy. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.